You learned in an earlier lesson how to make this choropleth map using Google My Maps. In this case, showing the median rents for various counties in the Nashville area. Uh, what's actually on the map are these polygons, these shapes indicating the borders of each of the counties that we're dealing with. And the shapes themselves have been color coded according to what the median rent is in that particular county. And if you click on one of the counties, like Rutherford County here, you get a detail window that slides into view and shows you what the median rent is. As you saw, these are kind of complicated to make in that you have to start out with a KML file, a particular kind of shape file, a geospatial file that will put the county shapes on the map, and then you have to come to the data window for the map and manually enter in the rent data for each county. A little tedious, perhaps, but the end product is kind of worth it. Uh, in this lesson, we're going to look at a slightly different kind of map, and I have an example here already made up that I want to show you. This is Rutherford County right here. See, it's the same shape as Rutherford County on the map here. So it's just Rutherford County, just the Rutherford County borders, and it's got these dots on it. And each one of these dots represents the location of a structurally deficient bridge in Rutherford County. These are real data. They came from here, from the Federal Highway Administration's National Bridge Inventory. That's what the NBI stands for. And I actually downloaded them from this link right here. This is the 2020 data, currently the latest available data. Now, and I've put the data, by the way, in this spreadsheet, which I'll provide for you. There are way more bridges in Rutherford County than just what's here. These are the bridges in Rutherford County that had been deemed structurally deficient. That doesn't mean, by the way, that they're about to fall down. If that were the case, the Highway Administration would shut the bridge down, which does sometimes happen. But what it does mean is that these bridges have maintenance problems that, if not corrected, eventually will begin to undermine the structural integrity of the bridge. And so these bridges get inspected on a on a rotating basis every couple of years at the very least, sometimes every year. And engineers look at them and determine what kind of condition they're in and then report on them. And obviously the ones that have been flagged as problematic somehow end up on this list. So these are just the bridges that have some kind of structural problem. In particular, they have a rating of 4 or less on one of these variables. There's either a problem with the deck, that would be just the surface of the bridge, the part that you drive on, or they have a problem, a 4 or smaller score with the superstructure. That's everything above the deck. Railings, if it's a particular kind of bridge with girders or beams or whatever overhead, that's the superstructure. The substructure is everything below the deck, the piers, things that are holding the bridge up. And in special cases, it's not a bridge at all. It's just a culvert. It's a channel underneath a roadway that carries a stream or some sort of body of water. But those can become structurally deficient as well. So they're in the database as well. So I got this data, or I should say I distilled this data from these big ASCII files here, which are quite large. It's a nationwide, well, actually, by the time you download it, it's every bridge in Tennessee, whether it's structurally deficient or not. And there are all sorts of variables for every bridge. It's a huge data set. And if you were to try to do this yourself, what you would also find is that the latitude and longitude coordinates for each bridge are in the degrees, minutes, and seconds format, which is an older format and is not a format that computers these days can typically do much with or read. So I had to convert those older sort of legacy latitude, longitude coordinates into these decimal equivalents right here. The latitude is here, the longitude is here. These decimal equivalent or decimal format latitude longitude codes can be read by most mapping programs and such today, including the one we'll be using, which is Google My Maps. The main thing I want you to see is that once you get all this data distilled, okay, it becomes really easy to get this data onto a map. A whole lot easier, actually, than the process that we used to produce this choropleth map, where we had to import the KML and all that sort of thing. What will happen is you can just import this data directly onto a blank Google My Map and tell it that the latitude and the longitude columns contain the geocoded data, and it will use that latitude and longitude to position a point on the map for each of these bridges. And these points are interactive. If you click on one, you can see that all this information slides into view. This is all stuff from the database for those bridges. There's the name of whatever the bridge goes over. In this case, it's Stewart's Creek. There's a unique ID for every bridge in the United States. That's that right there. Tells you who is maintaining the bridge, if it's the federal government, the county, the state, or a local government like a city government. Tells you when the bridge was built, what year, if it has been reconstructed, what the most recent year was. An interesting number here. This is the average daily traffic for the bridge, the average number of cars or vehicles that cross the bridge on a typical day, what it's made out of. Here are the ratings for the different parts of the bridge. So in this particular one, the deck's okay. The deck's greater than 4, so it's fine. Superstructure's okay. It's the substructure on this particular bridge that is problematic. It's not a culvert, and it is a bridge instead of a culvert. And this is the kind of work that's needed on the bridge. It needs to be widened. And there's the estimated cost of the work, $319,000. So some of these are just little bridges that you probably never drive over. This one out here is kind of out in the middle of nowhere. The average daily traffic here is just 170 cars. Okay, so that's that's not a bridge that most people are even familiar with. Here's one you probably do know about. This is the big bridge on Church Street. Let's see, where's campus? Here's campus. Okay, so if you leave campus, come down Middle Tennessee Boulevard, and turn on to Church Street. Let's see, get my bearings again. Here we are. Well, I guess if you come from the courthouse, let's do that. Come from the courthouse, go south on Church Street. Eventually, you're going to go over this bridge. It's the bridge over the CSX railroad tracks there, and it is not in awesome shape. The bridge and superstructure are 5, so they're getting close to the dangerous range. The substructure is a problem on this particular bridge. I've actually been underneath this bridge and looked up. You see all kinds of cracks and falling concrete and spalling, which is concrete that is crumbling away. And it's the crumbling concrete itself isn't necessarily the problem on these bridges. What happens is the concrete provides like vertical strength for the bridge. It means that the concrete piers, for example, are holding up the roadway for the bridge. That's critically important. But the other thing the concrete does is it encases the metal parts of the bridge, particularly those that give the horizontal portions of the bridge their strength. So this would be like a reinforcement bar or rebar made out of steel, and the concrete encases those metal parts, and when it encases those metal parts, it keeps them from rusting. And that's the main function of the concrete for those components of the bridge. So when the concrete cracks or falls away, it exposes that steel rebar to the elements. The rebar begins to rust, and as the rebar rusts, it loses strength, and the bridge begins to be in danger. So anyway, that's a long way of explaining what this map shows. And this would be a pretty important newsworthy map. These data get updated annually, and you can find out what the where sort of the problem bridges in the county are. One more thing I forgot to point out, wanted to point out when I was here, the average daily traffic across that Church Street Bridge is almost 21,000 vehicles a day. So this is a major bridge in Rutherford County. This is a pretty important one. And when they go to work on this bridge, it's going to be quite a job to correct its problems. The recommended work is actual replacement, no fixing this thing up, and the estimated cost of that work is about $13 million. So there you go. This is not a small job, but anyway. The other component of this map that I want to call your attention to is I do have this outline of Rutherford County right here. And this isn't critical, but I do think that it kind of helps you when you look at the map. It kind of helps you get an idea of where each of these bridges are. If you imagine the map without those Rutherford County borders, it might be a little tougher to get your bearings. So I'll show you how to add this sort of layer, if you will, to the map. But don't be worried about having to type in all of this information as you would have had to have done had you been working on a strictly choropleth map. This is a lot of information to type in. When you're just mapping points, which is what we're doing here, just mapping points, all this data can come into the map with the points and just be imported in bulk instead of you're having to type it all at once. One more feature of the map, by the way, I've used smaller dots, these little red dots here, for the culverts. So they're a little less significant perhaps than the bridges. So I used a smaller icon there. All right, so that's a quick overview of what we're going to be doing. I'll show you how to do all this in the upcoming video.